Assalamualaikum my dear students, how are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic chapter 9 extra CQ 1 and 2. Our today's lecture number 23 and interview number 18. My dear students, let's start our class. This is extra CQ number 1. First of all, see the stream. This is the figure. This one is air, medium, and second one is glass, and third one is water, medium. And here given the refractive index also A eta G, that means air to glass refractive index is 1.52 and refractive index of glass to water is 0.875. Now question number C. If the angle of incident in the air medium is 60 degree. My dear students, here given this is the angle of incidence in air medium. Here given the angle of incidence is 60 degree. Then calculate the angle of refraction in glass. The angle of refraction in glass we have to find out. So my dear students, first of all see the here given the angle of incidence, that is I, is 60 degree. Refractive index on A eta G equals to 1.52, here also given, and refractive angle R equals to what? We have to find out the refractive index of R in glass. So now we know the formula is A eta G is sin I divided by sin R. Okay my dear students, now here given this one is given 1.52, A eta G 1.52 equals to sin I means incidence angle I 60 degree here given, and we have to find out the angle of refractive angle, so R. So now put the value sin 60 degree, that means sin 60 degree here given, so sin R equals to sin 60 degree divided by 1.52. So my dear students, by doing this calculation we can find out that sin R equals to 0.570. Okay, now R equals to sin inverse. It will be sin inverse. If we change the side, then it will be sin inverse 0.570. So now by doing this calculation by scientific calculator, then we can find out that R is 34.75 degree. Okay my dear students, this is the refractive angle in glass. Okay, 34.75 degree. This is the required answer. Now question number D. If the velocity of the light in air is 3 into 10 to the power 8, then the 8 meter, then what is the velocity of light in water? Analyze mathematically. My dear students, this is also a mathematical type question. Here given that A eta G 1.52 and G eta W 0.875. The velocity of light in air given 3 into 10 to the power 8. Okay, that is C. We indicated the velocity of light in air by C. Okay, or C A. We can write CA also. So 3 into 10 to the power 8 meter per second, and velocity in water, that is CW, we have to find out. So my dear students, let's the light velocity in glass CG. Light the velocity in glass is CG. So therefore from from here A eta G, we can write the formula A eta G equals to C divided by CG, the velocity of light in air, and divided by velocity of light in glass. Okay, A eta G equals to C divided by CG. That means the velocity of light in air, that means CA or C, and the velocity of light in glass. Okay, so we can write also G eta W equals to the velocity of glass CG divided by velocity of the velocity of light in water, that means CW. Okay my dear students, then if we multiply this one, these two, then we can write A eta G into G eta W equals to C divided by CG into CG divided by CW. So CG and CG vanish, so we can put the value, that is 1.52. A eta G means 1.52 into G eta W 0.875. From here we can put the value and divided by C divided by CW. So my dear students, we have to find out the velocity of light in water, that is CW. So CW equals to 3 into 10 to the power C means 3 into 10 to the power 8 divided by 1.33. So CW is 2.25 into 10 to the power 8 meter per second. So my dear students, I hope all of you have understood this calculation. Practice this calculation at your home. Now come to next CQ, CQ number 2. Here given the picture, this is a lens, and here given the point P. This one is focus F, and this one is the double focus, that is 2F, and this is the center of the curvature, and this one is A. Object is A, and then the distance of the object is 25 centimeter, and the center of the distance of the center of the curvature from lens is 150 centimeter. Now my dear students, question number C. Determine the magnification of the image of the object. And first of all we have to write what is given. The given radius of the curvature from this figure, we can see that the radius of the curvature are given 150 centimeter. The focal length here given, focal length we know focal length F equals to R divided by 2. So here given R is 150 centimeter divided by 2, so it will be 75 centimeter. So my dear students, the distance of the object, from here we can find out the distance of the object also. Distance of the object U equals to will be 25 plus 75. 25 plus 75, that means 100 centimeter. The distance of the object here given 100 centimeter, and we have to find out the distance of the image, that is V equals to what. So from here we can write, we will solve this mathematical problem. My dear students, we know the formula is 1 divided by F equals to 1 by V plus 1 by U. Now put the value, just 1 divided by F, that means 75 equals to 1 by V, we have to find out, plus 1 by U, that means 100. Okay, so we will find out this value. 1 divided by V equals to 1 divided by 75 minus 1 divided by 100. So my dear students, we can write, we can take the LCM, that is 75 and 100, it will be 300. So 75 divided by 300, it will be 4 minus 3. So 1 by V equals to 1 divided by 300. So we can write V equals to 300 centimeters. So my dear students, the distance of the image will be 300 centimeter. Now come to question number D. Construct the image of the object for the positions A and P, then compare the characteristics between them. My dear students, we have to draw the two figure. First the object for position A, and another figure, the object will be situated will be the position P, then compare the characteristics between them. Okay my dear students, now here question number B, we have to find out the magnification also. Okay, so magnification M equals to minus V divided by U, so it will be 300 divided by V means 300 and U means 100, so it will be minus 3. So magnification will be minus 3. Now come to question number D. Point A is between F and 2F. My dear students, see this figure. Point A is between focus and the double focus, between focus and double focus. Okay, so when an object is placed between the focus and the center of the curvature of a convex lens, then a ray of light AO, which is parallel to the principal axis after refraction, pass through focus F along the direction of wave. My dear students, see this figure. This is the principal axis, this one is convex lens, and first of all the object is situated F and 2F, between F and 2F. So this one is AB is object. So first ray coming from point A, it will be parallel to the principal axis, and after refraction it will go through the focus point. Okay, Then another light ray coming from point A, it will go through the center of the curvature, and after refraction, these two lights, refracted light, will intersect at A point, and AB now will draw up a perpendicular from principal axis, and this one is AB, and this one is the image of, it will be A dash B dash. So A dash and B dash will be the image of object AB. My dear students, now I will draw this figure. See, this one is the principal axis. Okay, this one is the principal axis. Suppose convex lens, this one is convex lens, this one is the center of the curvature C. Okay, so it will be the focus F, it will be double F, that means 2F, it will be 2F. So the object will be situated at F and 2F, so it will be object AB. Now first ray coming from that one, it will be parallel to the principal axis, and after refraction it will go through the focal point. Okay, now another light ray coming from the center of the curvature, and after refraction it will go through this light. Okay, then these two refracted ray intersect at this point, and suppose this one is A dash B dash, and now we will draw a perpendicular from here, and A dash B dash is the image of object AB. My dear students, I hope all of you have understood, and you have described this like this figure. Now come to question number next part. When an object point P is when an object is placed between the principal focus and optical center of the convex lens, then the parallel ray of light AO passes through the focus after refraction along the direction of OX. My dear students, now I will draw the next figure. This one is also principal axis, this one is a convex lens. Okay, this one is the center of the curvature, so it will be focus F, then 2F. Okay, now this one is also focus F, it will be 2F. So now the object will be situated at the focus and center of the curvature. That means suppose here it will be object AB. Okay, so first ray coming from A, and it will be parallel to the principal axis, and after refraction it will go through the focus point. Okay, it will go through the focus point. Another ray coming from A, and it will go through the center of the curvature, and after refraction it will go the straight line. Okay, now these two refracted ray, if we at this point it will meet at this point. That means suppose this one is A dash, this one is B dash. So now we will draw a perpendicular. So A dash B dash will be the image of object AB. My dear students, now from this two figure, we can see that the first object for first figure, the image will be large than the object AB, and it also here also the image also will be the large from the than the object AB. Okay, this one is real object and this one is unreal or virtual image. Okay, so my dear students, I hope all of you have understood this question number C and D, and your SW is today's SW number is 18, and CQ, stress CQ 1 and 2, CD as your SW. My dear students, I hope all of you have understood our today's topic. Practice properly at home. This to CQ. Submit your SW regularly. See you again in the next class. Allah Hafiz.